Okay, I got some vocal there, so we'll go back over here. This is the second part of BISS 4403. Last night we went basically 104 minutes. The 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 so we needed another 46 or 47 minutes to make the full 150 minutes. And in that screencast, we covered lunch's database 16. So today we're going to cover 17, right? And then all that we will have left will be 18. And I may try to pre-record it this weekend or this coming week. I'm not sure. I may. It just depends upon what I see is in there. Now, as usual, okay, I just want to, and I don't feel like last night I ran through what we have coming ahead of us, so you pretty much know what's going on. And I'm just going to focus on doing 17. All righty. Now, last night, as we saw, the chapter was pretty conceptual, and again, uh, because yeah, in that in that chapter, excuse me, we did cross joins, self joins, and crosstabs. Crosstabs, which I told you I absolutely hate. If you want to play with like crosstabs and go in there in that part of it and do it, that's fine. Okay. But I'm just not that much of a fan of crosstabs in Access. I like pivot table because I just feel like it's just it's much more flexible. But we did that, and we looked at the at the where we really move into some powerful stuff in database technology, where we talk about taking a table, for example, and using table aliases to basically duplicate that table, using column aliases to duplicate columns if we want to do that, linking them up and basically running a join on a self join. We also looked at cross joins, and we talked about that, the multiplicative effect that we get, and we saw how we go from this process of two tables, we join them, we get a result set, we extract even down more to that result set. And typically what we do is in data mining is we keep reducing the result set down to that point of down to the set of records that we want. Okay, and so we went through that. So I don't see any need there because you have the code. We did some of the code. We did a lot of visiting about the code because there in many ways was just not all that much to look at. Well, over on page 17, these are combining tables in a production database. Okay. And that's going to be over on page 653. So you'll want to go to page 653. Okay. I'll take a look at that. It's going to be 653. And if a production table sounds familiar to you, it should. Okay. Because we start off with the Access workshops working with production tables. And of course, I went through all of the assignments that are coming at the big projects and so forth. Now, in 17, what the authors tells us that we're going to handle some of the challenges in combining tables with a production size system. That's a much larger system than we've worked with at this point, okay? And so what we're going to do, and if you if you look over at page 654, you're going to see chapter 17 broken down into these parts. The methods of joining 3 or more tables, then the issue of losing information, and then the computer efficiency, a lot of it around, monitoring queries, using indexes, and then standardizing the manner in which tables are joined, okay? So we're going to start over here with the at the bottom of page 656, and this is Oracle SQL. Okay, so you want to look at page 656. We're in chapter 17. I'm going to walk you through what we're doing there. In the first table, in the first set of code, I would say that would be set A. We start with, okay, we take two tables, that's employees and the lunches, and we combine them. Okay, then in part B, all right, we replace that view, okay, and we combine two more tables. We take the combined table from part A and we combine it with lunch items. Okay, so now we have three tables we've combined. Now we call this a production database simply because I'm taking fact tables essentially, and I'm pulling them together and working with them. Just like I might have, hamburger and buns and maybe mustard or mayonnaise, whatever you use on them, lettuce, pickle, the whole bit. That's why we call them production tables. So over in 656, where they end with and b dot lunch date, okay. All right, we can adapt some code to SQL for that, but what they've done is they've created a view as a query by combining the employees and the lunches table, and we combine them where the employee ID equals the employee ID in both tables and the lunch date. Okay, then we replace that 17 view, okay, and we select everything out of a table B dot supplier, B dot product, B dot quantity, and B is the lunch items table. Okay, table A is identified in the from statement there as that 1701A view. All right, so now we've combined three tables. Then we follow the next step, okay, where we take this and we create a 1701B view. Then we create a 1701C view. Okay, you see what I'm talking about? This is a very bottom page 656, and this is the Oracle, but yeah, you can pretty much see it. We've got now we're working with the food table, okay, and that 1B view table, and so we now have yet another table we've created. And then finally at the top of page third, at the top of page 657, we create a fourth table, okay, and that's, and you can see the result set for that, okay, over the result table if you over on page 657. But as I said before, we call these production tables because they contain sets of facts, okay, and we just keep combining them till we get that final result set. Now we could take this result set and extract it down even further, and I talked about the ratio between records in all tables or tables versus the number of records that you eventually extract. There's a fairly good ratio between that, and it's interesting because information is primarily an extractive process. That's why we talked about what we call the wisdom triangle, where I have data and then I convert it to information, which is data I can use for decision making, and then I take information and I convert it to knowledge, which is information that I can use in a variety of circumstances, In other words, it's replicable. And then wisdom. And those are insights that you get from dealing with customers, dealing with supply chains, dealing with situations. And that wisdom piece is you just can't you can't program it. Okay, it's experience. It's experiential nature. Now, if we were in a course on knowledge management, we're talking about knowledge management. It's wisdom is that piece of knowledge management, and how do we capture it? How do we take somebody who, say, for example, who's been a major league catcher, for example, for 15 years? What do they know about the game versus a rookie? We couldn't even begin because they've been in so many situations, okay, that they understand what's going on. And those of you who attended the speaker this morning, he talked about the speed of the game, okay? And so that's wisdom is you learn the speed of the game, and you see it because you've taken all of that knowledge and you've gained some wisdom. Okay. Now, so this is a fairly important piece. Now, we talked about production tables earlier when we did the Access workshops. Okay. So this isn't anything new. But again, what I want to point out to you is two things. First of all, really three. Number one, you understand now, or should understand, why table integrity is so important. Meaning, you don't collect information, you never have a field in your database that you don't have data for. Okay, don't collect information you don't intend to use. It's nonsense. You're paying too much money for it. Never, ever, ever let a record be saved if you don't have something in a field. Because as we've talked about before, the problem, what we call the problem of nulls, we don't know if that null means somebody forgot to enter the data. We don't know if it means a zero. We don't know what it means because null is meaningless. So we don't want to get a record. So what we want is that table we see, the result table at the bottom of page 667. Now, what can I do with this? I've got all of this data. And this is really now a facts table, i.e. a result table from a production database. You know, the truth is we've really been using SQL Fun. Our database is itself, okay, it's a production database. It has all those tables, and we just keep running queries off those same tables. Okay, so we can see that page 5 at 657. Now, again, over on page 658 of the text, listen, it's up to you to have the text open so you can learn this and understand this. Okay, it's your choice. You're big people. Most of you are juniors and seniors, and if you just want to listen and not have your book open, that's up to you. But frankly, I'd have my book open and I'd be listening because I'm trying to help you understand the power of these. Now, in addition to a good table, the second thing is you need to make sure that you've collected the right data, okay, for your table. A table, no matter how well constructed, can be incorrect. It can be incorrect if it won't give you the information that you want. If I build a database of every student who attends Oklahoma Baptist University, for example, who's from the Dallas-Fort Worth metropolitan area, and I run that, I'm going to get data about students from that area. I don't have data in there about students from Tulsa or Oklahoma City or Little Rock or Kansas City, but if that's not what I needed or wanted, I have an incorrect result set. Okay, so I need to know what I'm after. This is why you've heard me say before, when people talk about dashboards, okay, uh, the question is, typically a dashboard is, what are the 4 or 5 things you need to know every day when you walk in the office, depending upon your level in the organization. Okay, and that's why when we did the access workshop, and I think we did some also in 1123. If you took data business problem analysis, we built a little menu that said, okay, run this query. Those are what we call standard or periodic queries. Okay, then there are those that are kind of serendipitous. All right, but we feed all this, and without databases, and we wouldn't have these so-called we wouldn't have these dashboards. You've got to have those. And where they become really powerful is when those tables are constantly being replenished. Okay, maybe by customers who log in, maybe by employees there at the company, but they are real time. Now, we're in a day and time where companies provide financials each quarter and then the annual, and then they'll do the earnings call. And so if you've had your intro to finance, hopefully you understand what they mean by earnings call. It's where the CFO from I don't know, GM sits down, and it's usually it's some kind of a video conference, or it's some kind of webinar, and they'll say, here's what we think we'll do next quarter. Okay, and then they'll get some questions from people about what's going on. I'm going to tell you now, we're coming to a point where everything is so fast, and real-time data are wanted and needed so quickly that the annual report will probably be replaced by a monthly report, and you'll get the same data set within 2 days that you would have had from a full year. That's how fast we're collecting data. That's how powerful these databases are. And when you do that, everything has changed. And if you came and heard our speaker today, you heard him allude to that, how fast things are changing. Okay, so if we look over here at page 658, as I mentioned before, like I did in 16, okay, but we're not going to be running that many queries. This is more conceptual than anything. You'll see there in 17.2, okay, now it is Oracle SQL, okay, and there's a couple of things in there I want to mention on that code. First of all, the NVL, that's for Oracle. You would change that to NV, meaning no nulls. And then on the dates in that query, instead of the single quotes, you'd put those dates into pound signs. So I'm gonna forage through here. Now I've got my SQL file over here on my desktop. All right. And let me find it. Okay, I know you're around here somewhere, my friend. It says, there you are. Now I'm going to copy this and paste it. And I'm going to call this Harmon Keith, and it won't be a copy, so it's going to be Harmon Keith LD 17. Okay. So I've got that in there. You see Cardinal Buddy. Let me, what? I've got my 17. And then, of course, I have over here my access code. So I'm going to open up the SQL file. I have it on your desktop because you'll be wanting to upload all of this. You say, now when you stop for a minute, look at all these tables. See, production tables, they're basically production tables are dimension tables or tables of constants that we can combine and produce a set of facts, a fact table, from which we can begin extractive work. And just, again, back over there on page 657, I'd take that table, throw it into Excel, and begin to do some analytics with it, or maybe put it into a pivot table and look at it, okay? Especially if I want to do some computational work, or I'm required to. Well, we've got this open, okay? And let's go ahead and get the code for 17. And we get the code for 17, chapter 17. And we're going to go in here and we will get the code. We're going to open this up. And they're going to give us Oracle 17.2. Okay. Now, here's where we're going to need, okay, to make some changes. And the NVL right here would be an NZ. That NVL means no nulls. NV in access means no nulls. And we'll come down here, and around the date, we're going to get rid of the single parenthesis, and we're going to put pound signs. Okay. As you can see, as you can see, there's not a whole lot difference in Oracle and Access. Okay, so let me open this up here. So I've got 17.2. Now, I'm going to put this into a little bit bigger font. Oh, it's in 18 already, so we can talk about it. I'm going to highlight this first part and, of course, walk us through and see what we're doing here. All right. Now, we're going to get employee ID, first name, last name, and that's table A. Okay. And then table D is description as food. So table D has a field or column called description, and we use an alias as food. And then we have a table C, which is quantity, and we're going to get the quantity from that. Then we perform an operation where we're going to take D.price plus D.price increase 0.10. Now we put the NV in there so there are no nulls, okay? And we take that sum times the quantity in table C, and we're going to call that as total price. And then down here in the from statement, we identify tables A, B, C, and D. And then we have the where statement, okay? And we have the conditions where we match those up. And then we order them, and that's it. So we're going to copy 17.2. Copy it. And I'm going to go back over here to Access, to SQL. And I'm going to click Create. Query Design. I'm going to close this off. SQL. And I'm going to run it. Okay, it says we have an undefined function in NV. Okay, my mistake. Folks, instead of NV, it should be NZ. I apologize. And the null function, no null function in Access is NZ. My apologies. That should work now. There we go. Now, as you can see, we've got this result set, okay, and we've basically replicated what was over on page 657. Okay. Now, the key thing about this, and the authors talk about this at the bottom page 658, is this, where we use the where clause to join several tables. We use where to join A and B, and then, well, we join A and B, and then we select. We have conditions for that, and then we basically join B and C. That's on that lunch ID, okay, and then we join C and D on the supplier field, and then we join C and D also on the product code, and we order it by the employee ID, and then out of A, table A, and then D out of description. Okay, so we're combining all of these, and that's the output that we get. All right. Now, so that and we're going to save that as 17.1. Okay. Actually, we're going to save this as 17.2. All right. Now, as you go along in the text over here on page 659, he talks about joining several tables using the from clause. Okay, and he gives you that Oracle code. All right, and we're going to go down to 17.3. Now, what we'll have to do instead of NBL, that's going to be NZ plus NZ. Well, I'm going to reverse that back. And I'm going to C. NZ time D process, so it's going to be NZ for null. We'll come down here on the date, and we're going to get rid of the single parentheses, and we'll put it in pound signs. Okay, and notice, if you look, there are three distinct parts of this query. First is a select statement, okay, and then the from statement, okay, which includes an inner join, really includes two inner joins, or three inner joins, excuse me. And we know that the inner joins are where two tables, we only accept the data where the tables are exact matches. So we're running 1, 2, 3 inner joins. Okay, and so this is 17.3, and so we're going to get this. I think we got the NZ out of there, and we're ready to do it. And then we'll click Create, Query Design. And there it is. And the result set, as you can see, we have a very, very sizable result set. And last night we talked about the law of large numbers, okay? And when you hear all these people talking about, oh, they can track me, they can target me, it's because they have these immense data sets that they can grab, okay, and mix and match things. And that's how they do it. Whoever they are, Facebook, the Russians, Amazon, whomever, okay, is this ability to combine these tables. And you know, here we did 3 inner joins. You could do an inner join, a right join, and a left join. You know, it's just really, the possibilities are endless. That's what makes this such a powerful technology, because we can really take sets of data and put them together, okay, and combine them, and then get an insight about a customer or get an insight about a product. And so that's why these are just such amazing things. So we're going to call this 17.3, okay? Well, we're going to save it as 17.3, okay? And now, again, if you look at the middle, of page 659, you're going to see where we combine these tables using the from clause. And then we've got 1, 2, 3 inner joins. Well, he talks about being careful with them, you know, and make sure there's a matching entry row in every other table. And he talks about left and right outer joins, which is quite true. You got to be careful about those. And here at the bottom of page 662, he shows us, and then 663, he shows us a series of steps, okay, to create a view. And I don't know, okay, that it's really going to do all that much for you. It's more like 17.7, all right? But here's the first thing we're going to do, all right? And I'm at the bottom of page 662. I'm going to create a view called 1707A, SEC 1707A underscore view, okay? And if you look on page 662, you'll see the left outer join, okay? And then we do a union. And remember, on a union, we get all the records. On union, we get unduplicated records, excuse me. And on union all, I get the whole kit and caboodle. Okay. And then we have that new select statement under the union, this top of page 662. And I finish up creating that 1707A view. Now the next thing we do is our second step is we create that 1707B view, okay? And basically I'm on page 663. We do a left outer join, then we do a right outer join, and that's that 1707B view. Now, and you can play with that code if you wish. What you're doing is you're creating a series of views, okay? And we talked about the difference. When you'll hear people, you're going to hear old timers like me say the view. What they mean is a query data set, okay? And we use the term view because what it means is we went into the tables, we pulled out some data, and so we get a picture of, we get a piece of the picture, the part that we want, okay? And then the table stays the same. I haven't altered the table. Okay? And the beauty of it is that when I add records to the table properly, my capacity to extract information is greater and greater and greater. The value of information, when I talk about the value of information, okay, a lot of times I think people go, what do you really mean? Here's what I mean. Let's think about for a minute the information content, okay, that's in the information content that is baked into whatever you're wearing today. Somebody designed the shirt, okay, if you got a shirt. Someone designed the undergarments. Somebody designed pants or skirt or whatever. Somebody designed shoes and socks. That had to be designed. It had to come out of the mind of somebody. It's information because it's a bunch of data put together into something that is for a decision maker. And that is, do we want to offer this thing? Okay. And then someone's got to market the product. Well, they've got to figure out how to make it. So that's some more information that's got to come bear. Then they got to figure out how to price it and market it. Then they got to figure out how to get it to you. I wish I've looked. My hunch would be that all consumer goods, the information baked into it is probably 90 to 95% of it. So that's why information is probably, other than people, the most valuable resource. Okay, because it's malleable. And remember, data that's current today becomes historic data, and you might need that historic data to do what? Compare performance in the past at some point in the future. You might need the data you have today to build a predictive model for tomorrow. And so that's why information is so powerful, why it's the most powerful and valuable resource short of human beings. Okay? And that's really all I really do need to tell you. That's why we stress so much when we put you through these courses. We call it business information, systems, and strategies. So you understand, how do I take information and make it something that use it in a way that I support company mission or company sustainability? Okay? And so our ability, especially our ability to harvest all this incredible amount of data, okay, is beyond capacity. I don't know how many times my wife and I sit down, we watch TV, and like most people, we start talking. We go, "What about so and so?" And inevitably, I might go, "Hey, we ought to Google that," or my wife will get up and go over to the computer and Google it. Okay, how did I watch TV without? How did I live without Google? Okay, how did I live without being able to go online and just watch for the weather? I can see the weather right now, where it's going to be, all of that. That's the power of all of this. Okay, and if you know how to build it, okay, then you can really tailor products. Information technology is really designed ultimately to do two things. One, to make sure that you have the best and most effective, and that you have the optimal internal operations. Okay? And then secondly, that you have information that allows you to have as intimate an experience with your customer as possible, so that at a certain point you're anticipating their needs. Okay? And our speaker today talked about Amazon, and he said, what's management principle number one? The customer. And when you go to Amazon, you've heard me say this before, Amazon is a recommendation engine. Okay? Amazon is your personal purchasing consultant. And they will suggest what you can buy, and you can go hunt, and you can figure out how soon it'll be there, and on and on and on. Incredible. Amazon makes more money using its AWS, its Amazon Web Services, than it does on its retail operation. A lot of people don't know that. You've probably heard me mention that before. The United States government, a lot of large companies use the Amazon Web Services, that engine, to help them manage all of their data. Okay? So, this is, as I said, these are more conceptual chapters than they are just grunting through and running a bunch of code. All right? So, that over in 662 and 653 is powerful. Now, starting with 663, excuse me, okay, and over to page 666, he talks about computer efficiency, using the indexes, okay. Select the data that you want early in your process, okay. And that's why I talked about having what I call table discipline, but also having query discipline. And that is being sure you know what you want. Okay? What is it that you need to know every day? And so at the bottom, in page 64, he's really talking about business intelligence and using the data to save summarized data. He talks about several ways of writing SQL. That's fine. Then he talks about standardizing the way that tables are joined, and that's really more for a DBA or folks like that. But what it is intended to do is to impose some discipline in the table join process. And if you know that and you discipline it and it follows a particular series of steps or protocols, then you can know when things are not right or when things are working. Page 668, and again, folks, listen, if you really have an immense desire, for example, on 668 and 669, to go through each of those steps, all right, and then save the view, and then run it again, and walk through those iterations, because he's going to walk you through page 668, 669, and then over to page 670, a whole series of steps. At the end, you're going to wind up with quite a table that's 24 columns and 74 rows. That's quite unusual that you'd have that kind of ratio. You have about a 3-to-1 ratio, meaning you have 3 rows or 3 records for every column or dimension. When you look at that, all right, then you may want to ask yourself, do I have extraneous data here, etc.? And that takes you over to the key points over there on page 671, and he walks about he talks about major problems when you combine several tables, okay, excessive use of computer resources. The bottom line is, with the cloud and with server farms, okay, our ability to collect stuff and categorize it and pull it up, in other words, to build tables is just, it's only, the only limitations, is how many data farms and how many server blades that Google could ever create for us, or Amazon or anybody else. Okay? And so when the author wrote this book, he's probably someone like me who came from the days when the database actually resided on your machine. Okay, and so you got to be careful. Today it's out there in the cloud, and I want to talk about that for just a minute so you understand something. When people talk about cloud computing, or I have all my data on the cloud, and you say, yeah, there's 2 million Google searches every minute. How does it juggle out? Well, the servers are designed, and server systems are designed to juggle that load and move resources where it's needed, just like the electric power grid or just like plumbing. Because what's happened is computing, okay, has now become as seamless as turning on the light, having the water running. Okay, I don't have to put a bunch of disks in my computer. I go over to the cloud, to my website, to wherever, and I have the data. Okay, and then with the speed of computing, that's what makes all of this possible. And so I want to take the time now. We've only run a couple of queries or so for 17, but that's okay. You'll want to save that and upload it, for year 17. All right, because as I said before, these chapters are more conceptual, okay, than they're more conceptual than they are just grind them out code, and that whole series of things. Again, if you really want to, you can work all the way through creating each of those views at the bottom of page 668 over to 669, ending with 670. I do add one thing here at the bottom, page 670. He talks about what we call ad hoc reporting. Okay, and he says sometimes databases are asked to do something that they shouldn't or cannot do. Okay, there's and the author's making a good point. This is why, okay, you've heard me say many times, if I've got to do some heavy lifting analytically, okay, computationally, I'm going to use, for example, this table I've got right here. I'm going to take this table, I'm going to export it to Excel and do all the stuff I can do with Excel. Okay, or you may have another client or application, but I don't think you can beat Excel. Okay, and one of the arts of this, of good data mining, okay, and one of the arts of using dashboards is knowing how to do that and being willing to do that. Okay, and go get those data and get those reports. And often what's going to happen is you're going to go to do a search and you're going to get a bunch of data, and what you're really seeing is a table. Okay, and then you're just extracting from that. Well, there's the key points over there he talks about over in page 671, and walks you through that in 672, and that's pretty much it as far as production database combining a bunch of tables. Okay, chapter 18 will be the last chapter I'll cover, and in that one we'll be looking at conditional statements, if then else, okay, using the if function and access parameter queries and subqueries. Okay, and these are some kind of specialized kinds of things. We'll do that in chapter when we cover chapter 18. Excuse me. So today, we have one last chapter, and that's going to be 18. All right, folks. I'm gonna save this and close it. Okay, I'm going to close off all the text file, and I'm going to come up here into the files section. All right, and I'm going to upload that SQL Fun 17. I'm sure I've got some other ones over there for you. Okay, and there's 15, there's 17, there's 16. Okay, LD 17. We'll open it up. Hope it will load. And there it is. Okay. Well, that'll take care of it for us. And I'll post this this screencast over in the announcements, so you'll have your full 150 minutes. All right. Thanks so much, everybody, and I'll stop the share and the recording, and see you all next Thursday.